Welcome to the session. Greeting of the day. In this class we are going to see about the resistance welding processes. Earlier to these classes we have already seen the various types of gas welding methods, the various types of arc welding methods we have seen. So this gas welding methods, oxyacetylene gas welding importantly we have seen, and later in the arc welding methods, the various methods of sheeted metal arc, submerged arc, GTW, MIG, plasma, all those things we have seen previously. And now we are shifting over to the third part of this resistance welding methods. In this resistance welding, few categories of spot, seam, projection, flash, but these categories are there. Those things we are going to see in this today's class. The remaining part also we have to see. Right. The resistance welding. In this resistance welding, the heat is generated by and resistance heating by softening. I can able to tell this is also a solid state joining process. We are not melting like we have seen in the arc welding process. Arc is generated and the base material goes to the melting point, melted, and the positive welding process takes place. Filler metal added, but here we are not adding any fillers, no fume, no flux, no gases, no smoke, nothing is there. Just a workpiece. We are going to heat the specific workpiece and we are going to apply the pressure when it is at a softened plastic state. That method we are going to use. Heat generation by an resistance heating for softening of the fairing surfaces. It means the surface which is we want to weld. Maybe the two surfaces which we want to weld, this is fairing surface. Otherwise the two surfaces which are going for the lap joint, these surfaces are called as fairing surfaces of the base material along with the application of pressure. So this pressure and resistance heating, this pressure and this resistance heating combinedly going to do in the resistance welding, making the softening of the material, makes the plastic state and developing the metallic joining occurs. At heat, the kinetic energy, movement of electrons and bonding, metallic bonding will occur on the metallic materials. These are all termed as this is also termed as a solid state joining process. Resistance welding, solid state joining. As only softening is there, it means the plastic state process is the only plastic stage. Right. So I am dividing this resistance welding into such categories of spot welding, seam welding, projection welding, offset and the flash butt welding. Totally 5 we are going to see in this resistance welding process. Now we will see the first general how the resistance welding works for spot welding process. So these are the various things we are going to see. The resistance welding process can be considered as a green process. Why it is called as green? Environmental friendly, no smoke, no effect to the environment. That is why we are calling it as a green process. It does not generate any gases, flames, and the metal arc is also not generated as like in the metal arc welding. In the gas, flames are generated in the MIG welding process. In the MIG we have generated. In the SMAW we have generated. But here we are not doing that. It is an environmental friendly. Yes, if the process reduces the operator fatigue. Why the operator fatigue is this? Because it is going to be automated. It is going to be automated. Machine is going to do. We are just fixing this machine. We are just fixing the workpieces. We are going to just on the setup. Then the automated pressure applying, automated resistance heating, automated semi-solid plastic state, automated welding, the metallic bonding will occur. So that is why it is easily automated. The heat generated in this resistance welding, there in the heat how is generated in the arc welding process through the electrical arc we have supplied. But here we are supplying the electrical resistance heating, the material is going to resist. And that resistance generates the heat, not possible to withstand. Then this resistance heating makes the melting of the material, and as the pressure applied, it is punched over the joining occurs at the specific point. The heat generated in the resistance welding is given by the equation of H equal to Ki square RT, where H is the heat generated, K is a constant, and I is the current how much applied for generating the resistance over the workpiece. R is the resistance of the joint, and the time of flow, capital T, is the time of flow of current. So the resistance R is dependent upon the resistance R, and these constant values are dependent. How the resistance are dependent? With respect to the workpiece what we are using. The stainless steel having some other resistance with respect to current. Aluminum has a good conductivity, which is having some other resistance with respect to passing of the current. Casting some other resistance. Titanium some other resistance. Copper some other resistance. With respect to resistance, how much it is resisting the passing of the current. If the conducting is more, less resistance will be there. Less heat will be generated. At that time you have to pass more current in such a way some heat generation will occur due to flow of electrons. So with respect to based upon the workpiece such as the stainless steel, such as aluminum, such as steels, this workpiece resistance changes, and also resistance changes with respect to the thickness of the specimen. We know stainless steel we are taking, but thickness is 10 mm, thickness is more than 5 mm, then this current again the resistance increases. What is the electrode we are using? What is the gap? How much gap we are giving between this passing electrode and the workpiece? Or two workpieces, lab gaps. Or the electrode and this workpiece. What gap we are using? That gap resistance also are dependent and makes the factor of this resistance values. The resistance welding process can be considered as a green process, and the critical variables of resistance between the two workpieces and the resistance are themselves. The contact resistance is affected by the surface finishes on the plates. Now we are going to talk about how this resistance value are affected. We know thickness, we know electrode type, we know what material we are using. Depending upon the resistance also changes, and also the contact resistance. Now we are going to do the joining of two pieces here, maybe the butt joint or maybe the lap joint. We can able to do the welding. So this contact surface to be smooth, flat and in contact 100%. Then only all zones will be generate heat and a proper welding process will occur. Now irregular surfaces are there. How the irregular surfaces will be? In case some irregular surfaces, I want to do the welding here, some irregular surfaces are there like this. And one side exact flattening is there in this side. So what happens? These two surfaces when coming in contact, when coming these locations in contact, there is a gap between these two. This contact are not the same, surface finish are not good. If the surface finish are not good, contact will not be proper and current passing will not be proper, resistance heating will not be proper, therefore melting or plastic stage will not form, welding will not form finally. Therefore the contact resistance affected by the surface finishes. Therefore it is affected by the surface finishes of the plates. Contact resistance also affected by the cleanliness. I have talked about 2 points here. One is the surface finish, this point number 1. And number 2, this is the cleanliness of the surface. In case any dust is there here, in case any dust is there, surface finish also, then also the heating needs more. So dust also blocks the flow of electrons, the resistance heating. Therefore that also to be checked before going for the welding process. Some oxides, flame also will be there, some contaminations also will be there. Third point, contaminations will also will be there. So these all things disturb the passing of the resistance heating. This also to be verified before going for the welding of things. Now I am coming to steps involved in this welding process. The resistance welding has 4 major steps. Of number 1, I am telling the squeeze timing, and then the weld timing, holding time, off time. So these 4 are there. One by one you have to see. The name itself says what is resistance welding. We are going to take 2 specimens in this format, and we want welding here in this location. We want welding. So what I am doing? So first I am squeezing this 2. I am keeping arrangement and squeezing this 2, pressing there, and then welding time. What is welding time? Heating to be formed. Then automatically plastic state will form. Then automatically we are already applying the pressure here. Force is applied. Force is applied here. Automatically due to this pressure, due to this resistance heating, due to the plastic state, welding occurs. How long? We need to hold for a while. Until then, it will become plastic to room temperature. Heating temperature will reduce, and then we can able to off. That is what here the graph shows. One by one we are going to see. Number 1, the squeeze time. It is a time required for the electrodes to align and clamp the workpiece together and provide necessary electrical contact. See here in this picture, this is a lower electrode. Let us consider this is fixed. This is fixed one. And upper electrode, after keeping downwards, we are keeping the lap joints and we are going to press and making the contact fitting process completed. Where is the welding to be done here? The welding to be done in this location. At the center where the contact occurred, there the welding starts. Now, this is the squeezing time. Squeezing time, I have started squeezing now. Fit up ready and squeezing starts here. How long? The squeezing time up to here. This is the number 1 squeezing time. Squeezing time. And then number 2, the welding time occurs. What is welding time? We have to pass the electrical current there, and then resistance to be formed there. Heating to be absorbed by the material. Due to that heating, melting occurs. How long? So the next reason, I am calculating from here to here. Here to here, the electrical force is applied. It means the welding current is passed over there. That is why these waves of alternating current we are supplying. And then we can able to tell this is the welding time. This is the welding time. Now the welding heated, already pressure is there and force is applied and welding is done. But the specimen at a high temperature, you see, here there is no welding nugget like this. This is the starting. Just that is why I have mentioned here. That's why I mentioned here, but it is not actually. You see? And then from here to here, the welding started here. See, lightly the welding started. Lightly the welding started. And then there, it lightly increasing our pressure. It is here the welding completed. The weld zone is this one. The nugget where the force, the point of electrode in contact, that point is resistance heated, that point is welded. That we name as a nugget joint. A small point like welding will occur there. That is called as nugget. So welding completed. But it is in a red hot condition. It's to be solidified and come to the room temperature. Therefore, I am keep on holding the third one. Squeezing, number 1. Number 2, welding. Number 3, I am holding here. After this, we can able to put another color because here the welding completed. Current is not supplied. So I am putting here in this way. This is holding. But pressure applied. Pressure applied. Okay. Now, after this, here the pressure increased. Welded. Still the pressure is there. Along with pressure, heating. And then electrical circuit down. Electrical circuit is not supplied. But the pressure is keep on holding time. Now the holding is over. The material specimen come to this. From the red hot condition, it come to green condition. Solidified. Now we can able to remove the specimen and we can go to the next point. Multiple welds will be done. It is automated system. It is considered automobile, a car setup, a frame. There we are connecting 2 sheets and we are welding. This resistance welding heating for sheet material, for thickness of 3 to 5 mm maximum, we can able to do. In the car automobiles, we are having the sheet of 3 to 5 mm. So that sheets can be resistance welded at the multiple joint locations that we are doing. So what is this? The last one I am calling this is this BSC. The pressure is removed. From up to here the pressure is applied. Later the pressure is removed. Here started, pressure continues to apply for 3 stages. Welding, a current applied for only one stage, that is welding stage. And then pressure applied up to holding. Then pressure is removed. And this is called as off. It means we are replacing the next point. Again what happens? There is the graph again. Here from here after replacing, again the graph goes. Pressure apply and welding. The graph continues. This is how the various stages are there in the process of squeezing, welding, holding and off time. So we will read here. The welding time, it is a time the current flows. It is a time where the current flows, this region. Current flows through the workpiece till the heated to the melting of the temperature occurs, and then it is joining will be done. The whole time is the time will, next to holding. I am talking about the second zone, this zone. Holding time is the time till the pressure is maintained without the current. This point is important, without the current. Wherein the pieces are expected to get forge welded, but pressure is applied. Plastic melting is ready, but it is to be pressurized. Then only the metallic jointing will occur. Therefore, we are holding pressure there. We are not having fluxes. The material what we are using, in case we are using the specimen length of 50 and one more specimen length of here 50, after welding due to pressure applied, the specimen will become shorter. Specimen will become shorter here because here the welding occurred here, this point. Here this welding is occurred. Therefore it becomes shorter and it becomes maybe here this side 48 and this side 48 because it's a 2 mm's or by the pressure it is plasticized and welding occurred here. The compressor applied there. Therefore it becomes the size reduction in the workpiece will form there. No fluxes to be remembered. Then off time. What is this off time? When the pressure is, the electrode is taken out. When the pressure on the electrode is taken off, so the plates can be positioned for the next spot. For the next spot, we are moving to the machine to the next point, welding. It is automated. In a minute, we can able to do 30 joints, 30 spots welding we can do. For example, I told you. So what is the advantage and in general? Rapid operation. Yes, it is the rapid operations are there. Then can be fully automated. Yes, no filler, no shielding gas, no flux, no slag. These all words are related to the arc welding. But it is not here. Skilled operator not required. Skilled operators are not required. Why? There the 1G portions, 6G portions, they very difficult. Two-time handling, TIG welding process, fillers, guns, nothing it is here. We are simply, lap joint is kept, the machine is going to operate and they are going to weld there. Dissimilar materials, a lap joint, one piece can be stainless steel and one more piece can be another combination of we can able to do welding. Thicker ones, high reproducibility, automated system, what current supply, what thickness it is. For 3 mm thick sheet, we are applying the 90 amps of current, the same joint will occur again. That is called as reproducibility of the same result. But in case of manual, the hand movement, the speed, all things done by manually, it varies, it's not automatic. So the reproducibility we may not get. So minimum cleaning, there is no slag, fluxes are not there, cleaning also not required. High initial cost, the automated system, high initial cost, restricted few types, mostly the lap joint we are using, one over the other and making the joint there. Skilled operators for servicing the machines, therefore the skilled operator here. But see here, the skilled operators are not needed. Skilled operators are not needed for welding. Skilled operators are needed only for repairing works they need. That's the point. The surface preparation is required for special materials. Some that surface cleaning, small smooth surfaces, contaminations removal, those things are there for the before welding method. And high radiation, sometimes the flashes formations will be in high radiations. Applications, therefore we can able to do similar or dissimilar materials. Yes, commonly used for sheet metals up to 3 mm. Used in the electrical, aircraft, automobiles. So this is what we have now. We have told some example: cars, frames, joining. Home appliances, in batteries, for nickel cadmium cells, the cells coverings, metallic joints in the denser and medical instruments we are using, metallic ties. We have seen some simple nothing. Lamp we are keeping, pressure we are applying, heating occurred there and joint. Some examples of joints occurred over there. See, these are the joints. These are the joints where it is possible here. Some joints, these points are all done by in the batteries are done by this resistance welding, auto-welding. See the frames, the frames are done by this resistance welding. Now only we are coming to the concept, the spark welding. The individual welds are produced by the momentary applications of pressure and the resistance into the workpieces. The workpieces are held together under the pressure between the anvils of the phases. What is the machine is started which applies the current, and therefore the resistance is generated in the point of contact. What I am telling, I have taken such electrode. Similarly, this side also I am taking one electrode, and in between these two I am applying the plate. This one, and one more plate I am keeping in this way. So where is the pressure location? Pressure location is this one. Pressure location is this point. Here, this zone. So this zone is going to be welded. Not here. Not here. The pressure location is where the current flow is going to happen. Where the current flow is going to happen here. We are going to attach to the power supply here. We are going to attach the power supply here. And we are going to supply. So therefore the current is completed here, but in between we are making the resistance heating through that point. If the flatness of the electrode increases, we can able to do the broad welding. If it is sharp, we can able to do the sharp welding here. The pinpoint, the nugget, the size of nugget increases as the electrode pinpoint width increases. If this is the causes, we can see this is the size of the electrode point. When I am increasing the point there like this, and then the nugget will be like this. So as the electrode width increases, the welding width also increases. So this is the general setup I would like to show you. Here this is the weld occurred. Two are there. This I told you. This one is fixed. Sorry. This one bottom or any one is fixed. This is fixed and this is movable. And force applied here. Electrode. Two electrodes or copper electrodes we are using for good conductivity. We are using for good conductivity there. So this is what the setup we have. Up to now we have seen. First stage 1, pressure applied, welding, holding, and then off time. We can write it here as a squeezing, welding, holding, and it is off. And if in next case also it goes like this. So likewise we can able to understand this various squeezing, welding, holding, and off time. So some machine setup will be like this. See, we have to keep our electrode here. We have to keep our electrodes here in this location, and we have to weld two butt joint locations, and we have to weld. Here the welding will form at this point. So some colored images for our understanding. The workpieces has been given, force applied, welding started, solidified, and then it will become removed for the next one. for spot welding. So this is how the few are there. Stud welding we call it. It's a variant of resistance welding used for stud. The bolts we are doing, a simple bolt and a nut are there. I have to make a joint here. So we have a bolt and we are pressing, and it is called a stud welding process. Stud welding used for joining of these bolts in one shot. Reduce the valuable time. Time is reduced. It is automated. Uniform welding, as similar, as same parameter, same output will come. Reproducibility, automatic process. So here I want to show you one small video clip for our better understanding, like this.
我现在正在也是啊，3回是吧啊？
we have completed the spot welding, we have done. Now we are going for the second one of a seam welding process. So this one we have done, spot welding at one location. What is the seam? We are going to do a continuous roll. A continuous roll. We are going, instead of this electrode, converted into the roll format. That is what we call as seam welding process. In this another variant of a process, resistance welding process, where the seam of continuous weldings can be generated. Continuous weldings can be generated resembling the seam of the cricket ball, like it looks like that. We will see. The seam consists of a series of overlapping spot welds. How I am telling, you see, here one we have done. Here one spot is done. Here I am doing continuous spots, continuous spots, continuous spot. So it is like a, it's like a seam on the cricket ball. We have seen a thread over there. It looks like that, just for example. See, but it is a continuous spot. That we call it as a seam welding method. It is a spot, it is a spot, it is a spot, it is a spot. But when it is continuously we have done, we are calling this as a seam welding methods. But what we are using instead of the fixed electrode, we are using a roller for the continuous process. So overlapping sheets are gripped between the two rollers. See here, I have taken one roller and one more roller at the bottom, and I have kept an electrode here. It is rolled and it is welded. Current is passed over the roller, a continuous seam has been done, and overlapping weld nuggets one over the other. So like this, one over the other, overlapping other. Intermittent seams will form. The overlapping also we can form, or otherwise intermittent seam also we can give gaps. Welding current may be continuous in plates until the welding is completed. Keep on giving the supply to be enabled. So this is some image of this. See, we have the plate here, and we have to do the welding in this location. See, in this location I am doing welding between two. In this two I am doing welding. Roller, two rollers are there rotating. It has been connected to the power supply, and then the resistance heating will occur at this point, and this is the mixing zone. The exchanging point where the heat is resisted, then the heat, due to that the welding occurs by application of the roller pressure also, heating and pressure. So now I am telling, you see, the tack welding methods. We can see here, it is a conventional resistance seam welding method. What I am doing here, the seam welding has been done one over the other. See, and then in case the same roller, I am doing the spot welding methods. Here I have current has been supplied, pulse is stopped. Again the pulse given, spot welding done. Again the pulse given, spot welding done. When the current supply is continuous, then it becomes continuous spots. Then it is called as a seam welding. With respect to same roller, I can able to give the spot welding also. When the current, with respect to current variations, when the current is continuous, it becomes seam. When the current is not continuous, it becomes spot. So that is what continuous resistance welding that we can able to do. So see here, the tack welding. Here I have that, here I have it, here I have it. Then later I am overlapping the welds. I am overlapping one over the other, overlapping. So here it is fully, it is continuous process. We are able to do these things. In one case, the weld is made between two overlappings. Two overlappings are done. A sheet of metal, and the process is used to produce the liquid or gas tight sheets. How we are doing? We can able to generate a tight bonding sheets. We can able to make. See, a small clip I want to play here. See, they are welding, joining methods are done. How the roller methods we can able to do. A roller, a sheet, and here the fixed joints are made. For our understanding, just I have played here. So the overlapping weld nugget is maybe generally 10 to 50%. And then for water tighteners, I'm giving 30 to 40% of overlap. When as per the applications, if this resistance welded tank or covered over tankers, we have to maintain the water tightness. There we are using overlapping of 30 to 40%. Otherwise, if it is a gas tightener, it increases it from 40 to 50%. We have increased. There we have used the 40%. But here we are using the 50% of overlapping. It's been tightening. This tightening treatments are done 50% tightening, because here actually one weld is there. It is sufficient to do the other welding starting at here. But what I am doing, I am overlapping from here itself. So how much? 50% I am overlapping over the first joint. So that is how for gas tighteners. So this is tack welding, overlapping, and keep on running continuous welding process. So these three categories are there. So this is somehow just a sketch showing our machine setup that we have actually seen the actual machine itself. So this is how we can able to see this welding process. See how the welding has been done here. So two setups are there. Generally, two setups are there. We have to run, and then we have to go for the welding. So this is a two sheet. We have two sheets which are kept over one over the other for air tightening or water tightening, and we are welding. See how these corners or resistance heating is done here. In immediate time, we can able to go for long run. In case of when you are giving an arc welding process, what happens? Electrode changing, current changing, manual process, deferred comes, there is nothing here. See, simple rolling process which generates the welding methods. So it's very simple. Now they will show you after filling the air gaps, air tighteners or the water tighteners, we can able to use this setup. See how they are bulged. They are used for tightening setup. So these corners are belong to this seam welding methods. So this has some types. This in the seam welding, I am dividing this into three categories of lap seam welding. The name says lap seam, match seam, metal seam. What are they? So here I have kept two pieces as given, two pieces, and I am supplying the welding here. Welding has been done. This is lap one over the other. And next one, match seam welding. So how the setup I am keeping? You see, two pieces are kept as like lap, but there is a crossover there. There's a small crossover there. So that makes the match seaming. There's a meshing happens. And then again similarly, there's a small change in die. Where is the die here? It is not a flat, but it is going slightly inclined. So what happens? Here also small projection will happen like this, so that we call it as a metal seamed welding. So these are some of the types we have to understand. So what are the applications for seam welding? High welding speed at 82 meters per minute. 82 meters per minute we can able to weld here. So all material welding, dissimilar metals, high conductivity metals like aluminum and coppers, faster welding. So this is faster, belongs to this 82 meters per minute. Now only we have seen the video. Just a roller, and we are just it is a roller moving the object. Just keep on welding, continuous process. 82 meters per minute is too long. You check. Applications, what are they? So we can use in the petrol tanks, the roofs, the roller tubes or pipes can be welded. Two joints, the roller, and we are connecting a lamp, and we are keep on welding. Tubes and drums, automobile industries we are doing. So what are the simple limitations? Initial cost is high. Yes, we understand. Maintenance service cost. If the machine is to be serviced, this is to be increased. Thin sheets limited, which is very less than 3 mm. In the machine itself, we have seen sheets are the circular tubes and pipes are very thin, 3 to 5 mm we can weld. Or more than that, we have to give more resistance, more current. That is somehow some other difficulties will come there, distortions also. Right. The remaining part of the subjects we will see you in the next session. Thank you.